Let's see. Welcome everybody back from spring break. We've got two handouts to greet you all coming back. Two practice quizzes. The electronic versions are this POSIX 1 practice.pdf and this POSIX 2 practice.pdf file. Everybody had a good spring break? Thumbs up from Pedro. Okay, lots of people thumbs up now. That's good. Yes, hopefully that it was restful. You didn't have to spend too much time, or hopefully any time thinking about this class. We're gonna have a pretty intense next couple of weeks though. So yes, hopefully you got your break in. Today in class, we'll have a bunch of announcements that we'll go over, and then we'll get to the technical stuff. Let me make this bigger for us here. So I'm in the topic 8 folder right now on the GitHub repository. And the first thing is that this Wednesday, so next class period, we will have a quiz on the Object-Oriented Programming 2 material. So that's the quiz on this material right here with the different classes and more complicated class structures than we talked about previously. And we've covered everything that we're going to cover about this quiz in class, but there are some things here that we didn't cover, which will be on the quiz. So I want to just highlight those real quick to make sure that you are aware of that and take a look at that yourself. And that's in here, these sections that are related to built-in classes. That what we talked about was having class structures with subclasses and superclasses, where all the classes are things that you but you can extend other people's classes as well, including things like built-in classes. And so there's examples down here of extending the list class.
I think you're overthinking it maybe just a little bit.
And my expectation is that you will know how to interpret that and what these problems do, even though we didn't explicitly go over any of these in class here. There's the section 1.2 here, kind of in the middle, and then also at the very end, there's another section with built-in classes, again, about stuff that we didn't talk about in class, but will be on the quiz, and so I'm expecting that you'll be able to review that yourself.
It's like a red block? Is it exactly a red block?
The BST assignment, so that's what we were talking about Python-wise before spring break, the binary search tree. And again, the main purpose of the binary search tree is that it lets us do our insertions and our lookups quickly. The assignment for the binary search tree will be due not this Tuesday, but I extended the deadline to this Thursday for you. And then well, there's going to be a bunch of things for us to talk about related to scheduling stuff about my baby coming here. The due date is April 18th. Again, I'll be taking a 2-week paternity leave. The April 18th right here just happens to be exactly 2 weeks before the end of the semester. So assuming the baby comes on time, then we'll have our last day of class, and then there'll be no more live class sessions during the semester. I might make or post a couple of videos though, because you will still have a few assignments. Our tentative homework schedule for the rest of the semester is like this. So we'll have the BST tree, the binary search tree, and then the AVL tree is your next assignment, and the heap. Again, all 3 of these assignments are very closely related to each other. And this heap assignment down here is one that you're not going to be allowed to work with other students on. So when you're doing these 2 assignments up here, you really want to make sure that you're not just getting the test cases to pass, but you're getting a good workflow set up for yourself so that when you get to this assignment here, you'll be able to do it 100% on your own.
Just assign us a
After that, we're going to
project,
talk
a
about
parallel
something
processing
called
project
graphs,
on
making
May 2nd.
a little artificial intelligence for the Risk board game with
Not
that.
cool.
And then these 2 weeks off, no homework assignments for these 2 weeks. But there is this going to be this big final project about something called MapReduce. MapReduce is a technique for parallel processing, and we're going to use it for I have a data set of every tweet sent since 2017, and you'll be analyzing all of those tweets, finding some patterns in what people have been tweeting about. And in order to do that, since it's a very large data set, you'll have to be very careful with some of the things that you're doing programming wise, making sure your code's efficient and also making it happen in parallel. And so we'll be talking about how to do that. This project will have completed talking about everything you need for this project long before any paternity leave stuff happens. But this project is potentially computationally intensive, can potentially take a long time to run. So I'm making this the last thing that will be due in the class so that you won't have to worry about computation time. Or that's, I guess, the last thing due in the class for students who are graduating. For the non-graduating students only, there will be a project on something called asynchronous programming, and that'll be due the last day of finals week. The particular project for asynchronous programming, those of you who took CS40 with me, we did that war dialing assignment, and it was really slow because it was inefficient. And this async programming technique is going to be what we'll use to make our war dialing technique faster and efficient. Oops. It's a lot of, I don't know, administrative stuff, but any questions about what to expect administratively in the class? Yes. Yeah, so the question is about assignments while I'm on leave, that there'll be no assignments due these 2 weeks. So these are the last 2 weeks of the ordinary class right here. These last 2 assignments here, though, you will have while I am, I guess, yeah. So this is sort of, I guess, after my leave, but there's no more class sessions scheduled during this time. So there'll be these 2 assignments here. We'll have talked about everything that you need, though, for these assignments before I go on leave. Did that answer your question? Good question. Any other questions? Okay. Yeah, so because the baby might come at, I don't know, who knows when babies come. My guarantee for you all is that none of these due dates will be any sooner than I have listed here, but I might push things back and reschedule things around in different ways. And so I apologize that it's not maybe super set in stone. I know that can make scheduling or allocating your time for your classes a little bit difficult. But I appreciate your all being flexible with that. For today and for this week in class, so the main topic, again, is this AVL tree. This AVL tree topic, though, is not something that we're going to actually talk about in our lecture section. Instead, I have these 2 videos right here that you can use to understand the AVL tree and how to implement it. The videos go over both the high-level idea pictures of the AVL tree and also get into the homework assignment and what you need to do for the coding-wise for it, some coding tricks. I'm going to scroll down here to the very bottom here where there's the information on the what to do for the homework. And again, the instructions here are a little bit different than the instructions for the previous assignments. Because you're still working in your containers repository, you'll just be creating this new AVL tree branch. And pay close attention to these important notes that you'll be having to resolve merge conflicts and various other technical things here. Make sure you follow these instructions closely so that you don't lose any points on the assignment. There's a couple spots where you'll get pretty substantial penalties if you make, even if your code's all correct, but you have something wrong with how Git is working, you'll get these penalties. So pay attention to this section down here on the instructions. In class this week, we'll be focusing on the quiz material. So I have these again, the POSIX 1 practice.pdf and the POSIX 2 practice.pdf that we'll be going over in class. These are not the quiz for this coming Wednesday for next class period, but for subsequent quizzes. Again, the coming Wednesday is the object-oriented programming quiz, number 2. The one with the recursive data structures inside of it. Before getting into the actual quiz technical material, some high-level stuff about what we're talking about. So the idea of POSIX, what it stands for is it's a portable operating system interface. This is a thing that was invented in the 1970s, so it's very old, but it actually works on all computers everywhere in the world. Previously, before 2016, Microsoft was holding out, trying to make their Windows systems not be POSIX compliant. But everybody just realized that POSIX was so much better than what Microsoft had that Windows finally added support in 2016 for this POSIX compliance. And the actual topics in these quizzes are going to be more details about how the shell works and some weird edge cases relating to the shell. Some high-level ideas about why that's good. So advantages is that it's extremely useful for automating tasks. So when you boot up your computer, no matter what system you're running, there are hundreds of these shell scripts that run on startup that just get your computer into a working state. Again, it's easy to process huge data sets quickly with these shell scripts. So via MapReduce, this final assignment down here, this MapReduce project, in order to complete this, you'll have to be writing your own shell scripts using the techniques that we're talking about in these quizzes. And why is it shell scripts in particular that people use? It's because they're very powerful. There are Python programs, relatively long and complicated Python programs taking like 100 lines that can be done in 1 line of shell script. So we'll see that, especially when we get to the parallel programming part, that the shell script is much, much more powerful than Python in certain ways. It's also these POSIX shells, one of the most popular programming languages. So I have a link right here to this Stack Overflow survey. And every year Stack Overflow does a survey of their developers of what technologies people are using, what programming languages people are using. This one's the most recent one from 2022. And here you can see that here's where the bash shell script ranks. We have JavaScript, HTML, these are only for making web pages, SQL for analyzing data, Python right here, what we've been covering. This TypeScript thing is another variation of JavaScript. They're really the same thing. Java is like a more complicated version of Python, and then the shell scripting, what we'll be talking about. Sometimes shell scripting is called bash scripting because on most Linux systems, bash is the particular, what we call the flavor of the shell that's used on Linux systems. And most people who are programmers use Linux systems, but it's a little bit more general than that. We'll be talking specifically about only the features that are portable to every operating system everywhere, so Mac and Windows as well. The disadvantage, so why doesn't everybody just use bash or the shell for everything? It's extremely, extremely weird. And we'll get to that in these quizzes. We'll be highlighting some of these weird edge cases, and your quizzes will be focusing on these weird edge cases. Any questions at a high level before we get to the technical stuff? Okay. So the format of the quizzes is the same as all the quizzes that we've had so far. I give you a terminal session and you have to tell me what is the output of the last line of the terminal session. There's just going to be new terminal commands that are going to be happening in these sessions. Anytime you see the word shell, you should think terminal. Shell and terminal, sort of synonyms of each other. The first command up here, so in order to walk through these things, I have a terminal opened over here connected to the Lambda server. Our first command is the same thing that we've had for all of the other things, arm-rf quiz, make dir quiz, cd quiz. So that, cd first. And again, just a reminder, these semicolons are what connect multiple commands together so that they are, you first do this command, then this command, then this command, and so on. And this just gives us our clean quiz environment. I can run this ls program or this pwd program. They're, again, idempotent programs, so they don't change the output of anything that we're doing. And these this first problem right here, these first 3 lines are doing things that we've seen before. So we've seen that the echo program, if we do echo hello world like that, echo just prints to the screen. And then we can do this output redirection like this in order to, instead of print to the screen, let's save the output of our program to a file. And this works for any program, no matter what it is, whatever the output would have been. Instead of going to the screen, it'll go to a file. And what did I call it? It's going to README like this, going to README. And then the next line was, so we had hello world, then hola mundo, and then salve mundi like this. And this README file is now going to have 3 things inside of it, 3 lines inside of it, because we have these 3 output redirections right here. Again, we're using the double greater than sign right here, which means append to the previous contents of the file. If we had the single greater than sign, it would overwrite the previous contents. The thing that's new about this problem is in this last line, we have this vertical bar right here, and then this grep hello command. The vertical bar is pronounced as the pipe operator. We call this a pipe. We would read this as cat readme pipe grep hello. And on a US keyboard, it is the character above the enter key. It is the character above the backslash. And what this pipe does is it says, connect the output of the program on the left to the input of the program on the right. So we already know what the cat program does. Come over here, the cat program just outputs whatever the contents of the file are. So here our README file has these 3 lines inside of it. And so the cat is going to output that, concatenate that to the screen. The vertical bar, again, will take the output of this and pass it as the input over here. And so in order to understand this line, we need to understand this grep command. In order to see exactly what this grep command is going to do, I'm going to just run it by itself without the vertical bar. So over here, I'm going to type grep space hello like this. And the vast majority of these terminal commands, of these POSIX commands, when you type them in like that, you'll just be on this empty prompt right here. And it's waiting for you to type something in. And if I type in something like this is a test, then we'll see that it doesn't print out any output. What grep does is if a line has inside of it a pattern that matches this right here. So if it has the word hello inside of it, then the grep command will just print out that line again. So if I type out hello world like that, you can see that this is the line that I typed out. This is the line that got printed. If I typed in hola mundo, nothing gets printed. If I type world hello, then world hello will get printed again. So the grep command, the right way to think about it is as a filter, that it's going to only, it takes as input whatever lines it takes in, and it only outputs those lines that match this filter over here. So it's like the filter command in Python. Anytime you're inside one of these environments where you have a terminal program that's running and you want to get back to the main terminal, you can press Control-C or Control-D to get back to the main terminal here. And now we can combine together our cat and our grep program to see what they do together. So cat readme pipe grep hello. Anytime you're running these, again, you want to try to predict what's going to happen before actually running it. Where our computer scientists run experiments. And so, or we use the scientific method, we make a hypothesis, then run an experiment to test that hypothesis. And so my hypothesis here is that this grep program is going to match whatever contains hello. This line here contains hello. These two lines here do not contain hello. And so I think just this line right here will get printed. And that is in fact what happens. We just get hello world down here. So cat readme pipe grep hello gives me just hello world down here. Any questions so far? Yes. Yeah, great question. So the question is, does this grep program take regular expressions? And the answer is yes, it does. Actually, the RE inside of here stands for regular expression. And one of the subsequent problems is it has something like h dot star. Let's actually copy it. Well, we'll just go one line at a time. We'll do problem 2 here. We'll do just H by itself and see what happens. Grep H. You can see that that matches both hello world and hola mundo because they both contain the letter H over here. And the string doesn't, in this case, they're both at the beginning of the line right here. They don't have to be at the beginning of the line. If I change this to an O right here, then we get hello world and hola mundo as well still. If I change this to an E, then we'll get the hello world and the salve mundi right here. And then this problem number 4 right here, we have H dot star A. The dot star, what it means, H dot star A. This dot right here means match any character, and this star means that that character can appear 1 or more times. So if I hit enter right here, we have an H and then any number of characters, then an A. So the only thing that matches that particular pattern is the word hola right here. And so the word or phrase hola mundo gets printed out. For the purposes of your quiz, the only regular expression that you need to know, the only regular expressions that you need to know are the dots and the star regular expressions. This grep program was actually invented, though, in the 1980s. And if you've seen regular expressions before, all of the syntax that those regular expression things are using, they stole that syntax from grep. And so grep supports all of the regular expression syntax that you might want it to. Very powerful program. Good question. Any other questions so far? Okay. This, let's come back over here. We skipped over problem 3. Let's revisit problem 3 right here. And you can see now we have 2 vertical bars in this problem 3. In problems 1 through 4, the first 4 lines are all the same, that it's this README file always contains these hello world, hola mundo, salve mundi. The only thing that's different about each of these lines, each of these problems, is line 5 at the bottom here, and what exactly line 5 is doing. The grep command, again, does filtering. This WC command is another very important, commonly used command, and it stands for word count. So again, if I come back over to the terminal and I just type in WC like this, then I'm going to have this blinking cursor. It's just waiting for me to type things in. Hello world, this is a test, blah, blah, and so on. Here you can see that the word count program is not actually outputting anything as I am running, but instead it will output something as soon as I quit. I'm going to press Control D right here. And here you can see that there are 3 outputs right here, this 3, this 8, and this 37. It's very common in the Unix world when you have a program that outputs something for that program not to tell you what it's outputting and for you to have to know what these numbers are referring to. The reason for this is because it makes combining the output of programs easier to do together. In this case, what WC is doing is this first number here is the number of lines that we have. This second number here is the number of words that we have. in our input to WC. And this last thing over here is the number of characters that we have. A very common pattern is to only want to extract one of these three numbers. So for example, WC-L will give me the total number of lines. Control D, and it only outputs the number 4 out here because there were 4 lines right here. So in this problem, when I have cat readme pipe grep H pipe WC-L, you have to first apply the filter right here, grep H, to the contents of the readme file, and then count how many lines the grep output returned. Coming back over here, I'm going to do my Control R to get back to my command up here that I typed right here. I didn't want to use the up arrow. Well, I definitely didn't want to retype all that out. That was way too much to type out. I could have used the up arrow, but that's, I don't know, I'd have to count how many times this was. So I used Control R to search for the single quotation mark H, and that brought me back to this line right here. And now I can edit this line to add, well, I guess I'll first run it. So it has two things, pipe WC-L just gives me the number 2 right here. There's a very common pattern to use grep combined together with the WC right here. Also very common to have many pipes changed together so that the output of this program goes to the input of this, and the output of this program goes to the input of this. Any questions on the WC-L or anything so far? Okay. Again, with these quizzes, we'll be focusing on the technical, the what and the how, rather than the why. Your lab this week will get you into the why, showing you lots of interesting, motivating examples about why you would want to use this pipe. And you'll be doing some pretty cool stuff in just like a one-line bash program that you won't have to write the corresponding Python, but you could imagine that the Python will be like multiple hundreds of lines long, very complicated things. Okay, the ls pipe WC-L, this is a little bit of a confusing one right here. If I type ls by itself, let's do ls-a, so we have a couple things here. You can see that there are 3 files right here. We have the readme, the dot, and the dot file right here. When you use ls, ls is a weird program that behaves differently when it's combined with a pipe versus not combined with a pipe. And it's the only program that you have to know about that behaves this way. And the reason it behaves this way is that it does the thing that you would want it to do. If I do ls-a again, so you can see there are 3 files right here, but there's, if I pipe that to WC, actually I'll pipe that to cat like this. So by piping it to cat, I'm just saying what is the output of ls-a, send that into the cat program, and the cat program just prints the output to the screen. When ls is combined with a pipe, it is going to print one file per line instead of combining them together like this into one line. When it's in a human readable form, it combines these together in one line to make it a little bit nicer, easier for humans to read. But anytime it's doing a machine readable thing, so piping means that it's machine readable, it's going to do what's easier for the machine, which is 1 line per file. And so when I do ls-a pipe WC-L, the number is 3. So this pattern right here of doing an ls piping to WC-L is to count the number of lines, or count the number of files in a folder. This counts the number of files. So again, it's a very common idiom that people use when they're working in the terminal, piping ls to WC. And then problem number 6 right here, if you put grep in the middle, then you can count the number of files that match some particular pattern. Okay, most people find, I think, the pipe to be, it's different than Python, but it's relatively intuitive. And if you think about it, you can see why. It's maybe not obvious at first, like why people use it, but it becomes pretty familiar with some practice. What we're going to be talking about next, variables, is going to work very different in Python. And this is something that well, it's just very different than Python, so it's very confusing. I don't want to say that some people never fully understand it, but it will be the case for many of you that you will be able to like get to the point where you understand it just enough for the quiz, and then it'll be totally, you'll forget it instantly, and you'll have to look up this information every time you're using it. That's the way that actually most people work in the terminal, and there's lots of jokes online about how variables work in Bash and how it's just so confusing. The first thing about variables is that anytime you have an equal sign, so I'm going to use my reset command right here just to clear my screen and give us a fresh working environment. Anytime you have an equal sign, if I say something like var equals, then this thing to the left over here is going to be defined to be a new variable. So hello world like this. And then in order to use the variable, this is different than Python. In order to use the variable, you use a $sign. When there is no $sign out front of the variable must be the very first thing in the line, and you're defining the variable. If you want to ever use the variable, you must have a $sign in front of it to use it. And there we get hello world. If we don't have a $sign, then we just output var like that. We've seen this a little bit before in some of our other quizzes and labs. The first thing that is confusing is that white space is significant here. And one of the things that in Python, especially with the linting, is that you need to put the spaces between the variable and the equal sign. This would be valid Python, but this is not valid shell script. This is not valid POSIX or Bash script. Anytime you're defining a variable, you must not have any spaces anywhere in order to define the variable. So that's the first weird thing here. You can't have spaces right there. The next weird thing is, so we're going to actually do this problem 7 right here, up here. If I type, so when I did the echo var, we outputted hello world. But let's see what happens if, and let me do ls rm readme. So there's nothing in our folder right now. There's nothing in our folder. Let's see what happens if I do touch var like this without the $sign. Recall that the touch program just creates the file, and whatever is passed on the right hand side over here, it creates a file that corresponds to that. Let's delete that, and now let's do what the actual problem is saying, putting a $sign in front of var like this. And I hit enter, and I type ls right here. This might look like I created one file that is hello and world, but actually I created 2 files. ls pipe wc-l gives me a 2 right here. ls pipe cat gives me hello and world as 2 separate files. Another way to see that, ls-l, 2 different files listed right here. What's going on? The answer is that variable substitution here happens before arguments get passed to the program over here. And so because there's a space in this variable right here, when we do this $sign var, Bash or POSIX is going to substitute this and say this is equivalent to touch space hello space world. So my var variable is equal to hello space world. When I do touch $sign var, this $sign var right here is the terminal is literally just copying and pasting this right here. And so it'll be, this is what touch hello world, what this gets expanded to. And the touch program sees this as 2 different file names being passed in, because in the terminal spaces separate arguments to programs. And so it creates 2 files, hello and world. If I wanted to create just a single file, I could put this inside of quotation marks right here. So touch hello world like this. These quotation marks tell the terminal that this is all just a single parameter being passed together into this touch program, all as one unit. And so if I run that and run ls, we get, we'll do ls-cat right here. This command right here created this hello world right here. The file name containing the space was created with these quotation marks. This command right here, without quotation marks, created hello and world separately. So here I ran the program without using the variable, just manually substituting. If I want to not manually substitute, but have the program do it for me, then I have to put the variable inside of quotation marks like this. Touch $var will create the, let me go ahead and remove each of these. So there's nothing in here. If I run touch $var like this, that created a single file hello world. Single file hello world. So putting inside of double quotation marks, variables will get expanded. And this is what you have to do if your variable contains a space inside of it and you want it all to be treated as like one unit being passed to the program over here. I'll do one more variation on this and then I'll stop for questions. So in Python, there's no difference between single and double quotation marks, but in the terminal, in the shell, there is a difference between single and double quotation marks. If I use single quotation marks like this, then this variable right here will not get expanded. I type ls, and you can see that it created this $var variable, like a literal $var right here. So single quotation marks, variables do not get expanded. Single quotation marks implies variables don't get expanded. Double quotation marks, variables do get expanded. And no quotation marks means that spaces will separate arguments. This is the summary of what we've seen so far. Are there any questions about those variations, those differences? Beezer? Yes, this command right here. What did I do with that command? What's going on in this command is not part of the quiz material, so or at least at this point it's not. What I did though, so the RM right here, this parameter right here, or the reason I ran this is that I wanted to just reset my quiz, and I wanted to delete all the contents of the folder. It was basically doing the same thing as this top command up here, the cd rm-rf quiz, make dir quiz, cd quiz, just giving me a consistent quiz folder that has nothing inside of it. In this case, though, the way I did it, since there were these three files, I did rm. This is the first file right here. Hello, hello, delete that file. Here, this is actually the second file. Instead of containing things in spaces, you can use a backslash to escape the space. So hello world, touch hello \space world. That's the same as touch hello world like that. The backslash in the shell is something you can escape, just like you can escape other things inside of Python. So this whole thing is one file corresponding to this file getting deleted. And then the world over here is the last file getting deleted. So at this point, deleted all three of these files right here with this one command right here, this command right here. And we can see that when I ran ls right here, there was no files after that. So this command didn't make sense. It's not needed for the quiz. I apologize. I got a little bit ahead of myself using the backslash here instead of putting it in quotation marks. The important thing to make sure that you understand is what the quotation marks do and how the $sign gets expanded only inside the double quotation marks. Did that answer your question? Good question. Any other questions? Yes. Yeah, so the question here is when I did this touch $var, ls right here returns hello world and $var. And why do we get both of these things? The answer is that up here, when I did this touch $var, we created a file hello world with, and on this line right here, we can see ls contains this file, and then I did nothing to remove that file. So this ls right here contains this hello world from this command right here, and this command right here, touch $var inside of single quotation marks, created this file right here. In order to verify that, what I'll do is I'll type Control R, get my cd refresh the problem command down like this, ls, and if I do touch single quote var like that, and ls, now we have only the $var created by just this line right here, because we just deleted everything, refreshed our problem state with this line right here. So the question is, what if we define this var variable before running this command right here? And the answer is we have actually defined this variable. I'm going to press Control R and redo, look for the var equals that I previously ran, this var equals hello world like this. And I'll change this to echo just for a second to maybe faster illustrate things. Echo $var, this variable does not get expanded. It's just literally $var that gets printed. If I put that in double quotation marks though, it will substitute this value for the variable right here. Or if I take away the double quotation marks, it will substitute the value for the variable. So this really what's going on here, what the important part is the single quotation marks, and it doesn't matter whether this variable is defined or not defined. One of the, related to this though, one of the things that's very annoying about the terminal is that there are basically no error messages in the terminal. So here, the only variable that we've defined is this var variable, but we have not, let's say we have a typo. Let's say we do something like echo, and instead of VAR, type VSR, because the S and the A key are right next to each other on the keyboard. This is a typo that I make relatively often. And if I do that, there's no error message. Instead, what happens is that every variable that's not explicitly defined is implicitly defined to just be the empty string. So anytime there's a variable that's never been defined, this is just the empty string right here. And if we try to print that out or do something with it, it's just the empty string. So this is the empty string being passed over here to touch. And we do get an error message from touch saying that it can't create a file with no file name. But other commands, they can work with an empty string. We'll do that just fine. Did that answer your questions? Okay. Great question so far. Any other questions? The vast majority of points that people will miss on all of these POSIX quizzes will come down to how these variables are getting expanded and whether it's inside of single or double quotation marks. That it's very easy to get confused here. So make sure that you really focus on studying this concept, because all of the other quizzes are just going to build on this. You really have to understand it. So that takes us through all of these variables here up to problem 12. And we're going to see a new type of quotation mark now. So far, let me just reset right here. So far, we've seen single and double quotation marks. Now we're going to see what's called the backtick quotation mark. The backtick quotation mark. On a US keyboard, it's the key in the top left corner above the tab key, above tab, and on the same key as the tilde. And we pronounce this one as a backtick. It looks similar to the single quotation mark, but is not the same. The backtick has no meaning in Python and no meaning in most programming languages. But it does have meaning in the shell. And what it does is it executes the program. The backtick executes the program, or say executes the code inside of the string. So let's say I do something like echo hello world. This piece of code right here just prints out hello world. If I include that inside of backticks like this, this will run hello world, and the output of this program right here will be replaced with this string right here. So if we'll start with this, echo hello world, hit enter, that gives me just hello world. What's happening here is that the part inside of quotation marks, the echo hello world, gets evaluated and replaced with hello world. And then that result gets passed. So this part right here gets replaced with hello world, because that's what the echo command does. This gets replaced with hello world. And so echo just sees hello world and prints out hello world. A little more interesting example. Let me go ahead and clear out our folder here. A more interesting example would be, let's say I use the touch command over here, something like touch echo hello world, like this. Again, this whole thing over here is going to be replaced by the hello world string, not inside of double quotation marks. And so this is two separate files that have been created. Again, this right here is equivalent to just hello and world. And then we pass that to the touch command, and so we created these two files, hello and world, separately. These backticks, strongly recommended against using in practice because they are very confusing. And in practice, what people do is they would run this command instead. If you have a $sign in front of parentheses, a $sign in front of parentheses like this, runs the code in the ... So $sign parenthesis is equivalent to backtick with the ... inside of it. This is the recommended way of executing code and passing code that's been executed as a parameter to a function. But you will see people use the backtick as well. And so the backtick is something that you'll have to know. For the purposes of the quiz, these are only going to be like artificial examples of the backticks and the this $sign code evaluation syntax. The lab this week will get you more like practical examples of why you would want to do something like this. Here in problem 11 on line 2, when I say var equals, this is, so var equals $sign echo hello world, like this. There's a common use of these backticks or $sign syntax is to assign it to a variable first, and then use the variable however you would use the variable before, and you have the same behavior of the double and single quotes then on that variable. Question? So let's go ahead and clear off my screen. Right now, var is equal to hello space world. If I do touch $sign var like that inside of the double quotation marks, this is just a single file. These double quotation marks and the variable substitution and the command substitution up here very often combined together all in one. So if we take something like touch echo hello world like this, because this $sign is inside of double quotes, Basically, double quotes means evaluate all of the dollar signs before doing anything else. Because this dollar sign is inside the double quotes, this command right here will get evaluated. This will evaluate to hello world. It will be inside of double quotation marks, and so it will not, it will create only a single file hello world, which we already have, so it won't create a new file. If I took away these double quotation marks right here, then now this will evaluate to hello space world, not inside of quotation marks. And so this will create two separate new files of hello and world. So it's very important to pay attention to these quotation marks right here. Again, anytime you have a dollar sign inside of double quotation marks, it will be evaluated and it will be all kept together as the same parameter to this program over here. If you do not have the double quotation marks, this thing will be evaluated and it will be passed potentially as multiple different parameters to this program over here. If we put that inside of single quotation marks, then it'll literally create a file named $echo hello world. Questions at this point? Yes. This one? So there, yeah, question is, why did this code right here get evaluated? And the answer is that this, the dollar sign has two meanings. So dollar sign has two meanings. Without a parenthesis, it is variable substitution. With a parenthesis, it means evaluate the code, and is the same as the backtick. So this here is the same as the backtick. So this here does evaluate things inside of it. Did that answer your question? Okay. Okay, one level deeper about things. So if things weren't confusing enough yet, then maybe this will do it for you. So let's reset our problem right here. Totally empty. And what happens when we have nested quotation marks? So I'm going to do touch, quotation mark, dollar sign. We're going to evaluate this thing inside of here, and we'll do hello world like this. So notice that I have nested quotation marks here. That in Python, when you have quotation marks, Python never looks inside of the quotation marks, and it would identify this right here as an individual string. Because as soon as you start a quotation mark, it just keeps going until it finds the end of the quotation mark, and Python would identify this as the entirety of the string. That is not how the shell works, though. The shell goes inside of quotation marks and interprets them. Inside of this quotation mark, it realizes that it's inside of a dollar sign command, and because it's inside of a dollar sign command, this quotation mark right here actually starts an entirely new string. This quotation mark here is terminated by this quotation mark here. Then this parenthesis right here terminated by this parenthesis right here. And this quotation mark here terminated by this quotation mark over here. So this, go ahead and hit enter, type ls. You can see it created the file hello world because this right here prints out hello world. And then we put that inside of quotation marks and pass it to touch. The reason for this behavior, the reason for the behavior of allowing nested quotation marks like this is so that you can just copy and paste code inside of a dollar sign code execution block, and everything will work. You don't have to modify your code. You don't have to escape these quotation marks in any way. You can just copy and paste this inside of here, and the nested quotation marks, the shell will investigate inside of the string and realize that this quotation mark starts a new string and is not part of this quotation mark out here. Any questions about that? Okay, let's come down here. So this is taking us all through the variables section. And now we're on to for loops. So we've seen for loops a little bit in your labs that I just mentioned them in passing as a way to help automate some of your code. Now we're going to take a more detailed look at the syntax so that you can really fully understand what's going on and write your own for loops for other problems when it seems appropriate. Again, the quiz here just focusing on the what and the how, and the labs will focus on the why. So for this, let's reset our screen here. I'll press Control R, get back to the CD, and I think this problem, yeah, is for file in ABCDEF, for file in ABCDEF, do touch $ file, done. This for loop right here, this syntax right here means after the word for, whatever comes next is going to be a new variable that's being defined. So we're defining a variable right here. So that means that we do not use a $ to define the variable. And over here, when we access the variable inside of the for loop, we will have to use a $ to access it. So this $ file variable right here refers to this file variable right here. The syntax of for variable name in, and then all of the things that you're going to loop over. Again, in the terminal, anything, anytime we have a list or a set of things, they're always separated by spaces. So this will be interpreted as file will first be equal to A, then file will be equal to B, then file will be equal to C, and so on. I'll change this touch to an echo temporarily so that we can see that. And then whatever is between the do and the done, whatever is between do and done will be what's looped over. So I'll hit enter, and you can see that this command right here, this echo file, got executed once for A, B, C, D, E, and F. A, B, C, D, E, and F. If you're typing things in on the command line, it's common to make your loops just on a single line like this. You don't have to, though. I could do this. So I just copied and pasted this initialization line of the for loop like this, do, and then you'll see that I have a new prompt over here. The greater than sign prompt indicates that I'm still typing on the same command up here. And now I can type something like echo file and done, and this does the same exact thing. These semicolons up here, the semicolon separating these lines out from each other. Yeah, again, when you're typing things out, typing out code in the terminal, it's common to do it just on one line like this. If I press the up arrow like this, so this was my previous command right here. If I press the up arrow to go back, you'll notice that the terminal combines it all into a single line together for me so that I can edit the whole thing at once. That this thing is all interpreted just as a single chunk of code. So for file in ABCDEF, again, spaces are what separate the anytime you're trying to separate things in the terminal, spaces are what do the separation, and quotation marks are what say don't separate these things. So if I put quotation marks around A, B, C, D, and E, F like this and hit enter, now this file on the very first iteration, this file will take the value of AB right here because they're inside of quotation marks. The second iteration will take CD, CD, and the third iteration will take EF, EF. In this case, there's no variables right here, so whether you're using single or double quotes has no meaning, has no difference, has no effect. On the right-hand side, though, whether you're using single or double quotes will have an effect. Over here on this command right here, this $ file variable right here contains spaces inside of it. So using quotation marks or not will have an effect. I'm going to switch this echo command to the touch command to illustrate that. So do touch $ file. Again, here, we're going to be substituting each of these values, A, B, C, D, and E, F, into this variable right here, this $ file variable. But because there are spaces in these file names over here, because there are spaces in the contents of this variable, this touch will not operate on the entire thing as one unit. It will operate on each one individually. So if I press enter and then type ls or ls pipe cat, you can see that each one of these lines corresponds to a different file, and each file contains just a single letter inside of it. So even though I had quotation marks over here, this affected how the for loop was going, but it didn't affect how the touch program over here was combining things together because there's no quotation marks right here. I'm going to press Control R, redo this command, delete everything, type ls. You see that I've deleted everything, press my up arrow back to the for loop, and then put double quotation marks around file like this and hit enter, type ls or ls pipe cat. And now you can see that because there's quotation marks around here, and because these things are grouped with quotation marks over here, the file names that get created are lumped together like this. Any questions so far? A lot of things being combined together here. A lot of moving parts to potentially get confused about. Question, yes? Your question is what happened here? So what happened here is that ls, when it's outputting for human consumption, doesn't separate the files by line. So this just has these 6 files right here. ls, when it's outputting for non-human consumption, but for another program. So it's output, and ls knows that it's outputting for another program because it's being followed by the pipe operator right here, the bar. And so it has these 6 separate things, each file on its own line. This same pattern repeated down here when I type ls by itself right here. Everything gets combined onto one line. The ls program, just the way the Lambda server is configured, outputs, if a file name has spaces inside of it, it puts quotation marks around it. So we know that it's 3 different files right here because there's quotation marks around the spaces. But it's more obvious that it's 3 different files when I do the pipe cat, and we can see that it's on 3 different lines. So the reason we're getting different behavior between these 2 commands, or different behavior between these 2 commands, has nothing to do with this command that created the files. It only has to do with the behavior of the ls program, where ls for human consumption makes things on one line so that it's easier to read, but for computer consumption makes it so that every file is on one line so that it's easier for the downstream programs to process. Did that answer your question? So the question is, because here we have A, B inside of quotation marks, why is everything on its own different line? So if over here on the right-hand side, inside of our for loop, we have the echo command. Echo over here, when we have file equal to AB, this file right here, AB, will get substituted, and so it'll print it out on a single line. Here, when we're using the touch command, touch will have this right here will be equivalent. So that is equivalent. The variable substitution happens to look like A, B like this with no quotation marks around it. And so it's like touch A file and touch B file. In order to make it so that the touch command knows that these are the same file, just a single file, we need to wrap it somehow around, with quotation marks like this, so that the touch command knows that this is a single file name right here. The The way to do that is you put your variable inside of double quotation marks like this. So the only difference between this line here and this line here is that the variable $ file is inside of double quotation marks down here. It is not inside of double quotation marks up here. So because it's inside of double quotation marks, it'll be passed as a single thing over to this program. Because this is not in double quotation marks, it will be passed as multiple things over to this program. So the quotation marks only matter where they actually occur at. Over here on the left-hand side, they have quotation marks around it, so it affects the way the for loop happens, but this has no quotation marks around it, so it does not affect how the touch command happens. A slightly more complicated, maybe a significantly complicated, but slightly more complicated example is that what if we had a variable substitution happening inside of our for loop like this, echo A, B, CD like this. In this case, this variable substitution will happen inside of these quotation marks, and this whole thing will get replaced by CD inside of quotation marks. And so we'll get the same exact output that we had before. I'll delete everything so that we can verify that. We get the same output that we had before, these 3 files. But if I take away these quotation marks, so let's delete everything up here to the same for loop up here. What I'm going to do is I'm going to delete these quotation marks right here. So we have no quotation marks in the for loop right here. Yes, quotation marks in the touch command over here. In the for loop, this will be expanded and this will be equivalent to CD outside of quotation marks. And so the for loop will happen 4 times. This will be the first time, C will be the second time, D will be the third time, and then this will be the 4th time. And touch will get each of those things individually. And so the C and the D are not part of the same file name right here. Lots of subtle quotation mark issues in this quiz that you'll have to pay attention to. Coming back over here, that's getting everything in the for loop. All of these examples have various nestings of different quotation marks in different locations and how that works. For the quiz itself, the main thing that, or the way that I'm going to generate new problems is the code will just copy and paste one of these problems exactly, but then I will just substitute the quotation marks, changing a double quotation mark to a single quotation mark, or adding or removing quotation marks. So as you're working through these quiz problems, make sure that you not only understand exactly what the problem is doing, but think to yourself, oh, what if on this problem right here, I change this from a double quotation mark to a single quotation mark? How would that change things? Or if I change this from a double quotation mark to a backtick, how would that change things? Any questions about anything else in this quiz? Yes. Mm-hmm. Yep, so the quotation marks, I guess all the examples that I've done so far, the quotation marks were just immediately around the $, but they don't have to be immediately around the $. They can be anywhere. So let's go ahead, clear everything out. I'll do touch, quotation mark, A, B, echo, hello, CD, echo world, EF, like this. And these $ syntax, this gets evaluated no matter how many times there are inside of the quotation marks, no matter where they are inside the quotation marks, these get evaluated and substituted, and then the entire string is passed over to the touch program. Good question. Yes. So yeah, when you're defining a variable, the difference between double and single quotation marks is the same as they are everywhere. These two things do the exact same thing because there is no dollar sign inside of them. If we had a dollar sign inside, so hello, echo world, echo dollar sign bear gives me hello world, because this gets evaluated because it's inside double quotes. And if we change that to single quotes, then we just literally get exactly what we typed up here. Yes. Yep. So the difference between the single quotation marks and the double quotation marks, no matter where they appear, is just how they handle the dollar sign. That in the single quotation marks, the dollar sign is not evaluated. So single quotation marks, dollar sign is not evaluated, but double quotation marks, dollar sign is evaluated. And that doesn't matter if you're defining the variable or using a variable or inside of a for loop or anywhere in the terminal. That's always the behavior. That's always the difference between single and double quotes. Yes, question. Yes, dollar sign, then a word means that's a variable. Dollar sign parentheses means it's code. This right here is not inside of a dollar sign, so it does not get interpreted as code. See, so one of the main purposes of using these shell commands, it does make your typing in of things inside the terminal to be more efficient. But really what we want to do is, or what we're building up to, is what we're going to be automating a sequence of commands. So I'm just going to go over, get us some motivation for the next quiz here in the last few minutes of class. And we'll see what that looks like. Inside of, let's go ahead and clear this off. If I create a file, what's called a shell file, I'll call it script.sh. The .sh extension is a just tradition for shell scripts, although it's not required. And then inside of here, I can put whatever sequence of bash commands that I want to do. So I could have a for loop, something like for file in A, B, C, D, E, F. So what we saw before, do echo $ file and done. And then I can execute this bash script, sh script like this. The sh command over here on the left-hand side means that whatever comes after it is going to be a POSIX shell script that we will run. And this sh command just executes, so we can see it. It just executes this file on the right-hand side, one line at a time, A, B, C, D, E, F is the output from this for loop. And eventually we'll be writing these scripts that contain, I don't know, not too big, like 20 or 30 lines of code. And that's what you're going to be using for this, this MapReduce assignment that's coming up, to automate a bunch of processing for you using for loops. And there will be file like spaces inside of file names. And so you'll have to be very careful about how your quotation marks are lining up as you're writing these scripts. In general, if there's one thing to take away from this class about shell scripting, it's that anytime you access a variable, if you put it in double quotation marks, then things will do what you want. If you don't put it in double quotation marks, then things may or may not work correctly. So always access your variables inside of double quotation marks. We'll stop here for today. And then again, reminder, the object-oriented quiz on Wednesday, and we'll continue more POSIX stuff on Wednesday as well.